Hi guys, it's Derek here, and this is the second time that I'm doing a video on the list of data, formulae, and relationships in physics. And this is mainly for A-level physics, but there are some things as well that you can use for GCSE. So I've done a video like this before, but apparently from some of the comments, the audio was quite poor. So I'm redoing this video just to make sure that I get the sound quality a lot better. So there's quite a few things here. There is the acceleration of free fall, and acceleration is free fall in this case because the object is falling freely, so it's not being thrown down. If it had been thrown down, then this value of g would have been different. And then you have the Boltzmann constant, which has to do with gases. So this is one of the gas constants. Then you've got the Coulomb law constant, which is K equals 1 over 4 pi epsilon sub 0 is 8.99 times 10 to the power 9 newtons square meters per coulomb squared. Then you got electric charge, which is minus 1.60 times 10 to the power minus 19 coulombs. And you'll notice that an electron volt is 1.60 times 10 to the power minus 19 joules. So that's the charge and that's the electron volt. And the electron mass is 9.11 times 10 to the power minus 31 kilograms. Gravitational constant G equals 6.67 times 10 to the power minus 11 newtons square meters per kilogram squared. Okay, I'm just going to make this a bit thicker. So if I do that, it covers the whole figure. Then gravitational field strength is 9.81 times 10 to the power 9.81 newtons per kilogram. Permittivity of free space, which is epsilon sub 0, is 8.85 times 10 to the power minus 12 Fm to the power minus 1. That's farad per square per meter. The Planck constant 6.63 times 10 to the power minus 34 joule seconds. Proton mass. The mass of the proton is 1.67 times 10 to the power minus 27 kilos. And if you look at the unified atomic mass, is also 1.66 times 10 to the power minus 27 kilograms. Speed of light in a vacuum 3 times 10 to the power 8 meters per second. Stefan Boltzmann constant 5.67 times 10 to the power minus 8 Weber per square meter per Kelvin to the power minus 4. Then I've got some equations for mechanics, and in mechanics we have kinematic equations with forces, momentum, efficiency, work energy and power. So as the distance is u plus v, where u is the initial speed plus final speed v divided by 2 times time will give you the distance traveled. Just going to take that one. Then v equals u plus at, where v is the final speed, initial speed or velocity, final velocity, initial velocity, acceleration times time. And distance covered is also ut plus half at squared, where t is the time, a is acceleration of the object, and u is the initial velocity. And v squared equals u squared plus 2as. That's final velocity squared equals initial velocity squared plus 2 times acceleration times the distance traveled. So these are kinematic equations. And so these equations are for objects where we do not consider the force being applied. Then we have equations for forces where the sum of the forces or the resultant force, sometimes we call this resultant force, is actually mass times acceleration. This is also called Newton's second law of motion. Newton's second law. Then we have G equals F over M from F equals mg. And also F equals ma, where A is acceleration and G is acceleration due to free fall, which is what we did up here. Acceleration of free fall. Then W equals mg again. W is the weight, which basically these two equations are similar. Let me uncover this. No feel. Okay, so there we have it. Maybe just highlight it a little bit. And moment of a force is the force times the perpendicular distance from the direction of action of the force to the pivot. So moment of a force is Fx, where F is the force, x is the perpendicular distance. Momentum P is mass times velocity. Change in work done or in energy done is, or energy change is force times the displacement or change in distance. This one is equation for kinetic energy, which is half mv squared, where m is the mass and v is the velocity. And gravitational change in the gravitational energy is mg delta h, where m is the mass and g is the acceleration of free fall, and delta h is the height through which is raised. And this equation is for power, which is energy over time, or power is work done over time. So work done and energy are synonymous because when energy changes from one form to another, work is done. So that's why they are interchangeable. Okay. Efficiency equals useful energy output divided by the total energy input, or useful power output over the total power input. Okay, so that's mechanics. Electric circuits, we're going to start with potential difference is W over Q, which is work done divided by the charge. Resistance is voltage divided by current. Electrical power, power is voltage times current, or the square of the voltage, the square of the current times resistance, or square of the voltage divided by resistance, or W, the work done is VIT, where V is the velocity, I is the current, V is the voltage, I is the current, and T is the time taken. The resistance equals rho L divided by area. Current is the rate at which charge is passing through a point. And another equation for current is NQV times A. And then we can move on to materials. Density, rho is mass over volume. Stokes law, force equals 6 pi nRV. Hooke's law, delta F equals K delta X. Young's modulus, stress is force over area, strain is change in distance over the original distance, or the extension versus the original length. And Young's modulus is stress over strain. Just that over that. Elastic strain energy is half F delta X. For waves and particle nature of light, wave speed, the velocity of a wave is the frequency times the wavelength, v equal f lambda, and the speed of a transverse wave on a string. Velocity is square root of the period divided by mu, and the intensity of radiation, I equals P divided by A. The power of a length, power is 1 over focal length, and P equals P1 plus P2 plus P3, etc. Thin length equation, 1 over U plus 1 over V equals 1 over F. The magnification for a lens, M equals image height over object height. Is that diffraction grating, and lambda equals d sine theta. The refractive index, n sine n1 sine theta 1 equals n2 sine theta 2, and n equals c over v. Critical angle sine c is 1 over n. The photon model, energy equals Planck's constant times frequency. Einstein's photoelectric equation, HF, which is this energy here, equals phi, which is work function, plus half mv squared, maximum for the maximum velocity. The de Broglie wavelength, or de Broglie, lambda equals h over p, and this is the Planck's constant. And further mechanics, let's look at impulse. Force times time is change in momentum. So force times change in time. Kinetic energy of a non-relativistic particle. Kinetic energy is p squared, which is momentum squared over 2m. Then motion in a circle, v equals omega r, where omega is the circular velocity and r is the radius. Then period is 2 pi over omega. Force equals ma, so that's also equal to mv squared over r, which means A equals v squared over r. So this is replaced to get that equation. And acceleration is also equal to r omega squared. Centripetal force, F equals mv squared over r, or m r omega squared. Moving on to fields, Coulomb's law. The force between two charges, Q1 and Q2, is F equals K, Q1, Q2, divided by the distance between them squared, where K is 1 over 4 pi epsilon sub 0. Electric field strength. Electric field strength is force over charge, F over Q. E is also equal to KQ over R squared, and E equals V over D. Electric potential, V equals K, Q over R. Capacitance, capacitance equals charge over voltage. Electric energy stored in a capacitor, W equals half QV. Capacitor discharge, Q equals Q naught e to the power minus T over RC, where R is the resistor, size of the resistor, and C is the current. I mean, not the current, but the capacitance. Resistor capacitor discharge, R equals I sub 0 e to the power minus T over RC. You can see how these three equations, this one, this one and this one. 1, 2, 3. Sort of are similar. In a magnetic field, F equals B sine theta and F also equal to BQV sine theta. Faraday's and Lenz's law, epsilon is minus D N phi divided over dt. So the rate of change of the magnetic flux. Root mean square values. The root mean square velocity, not velocity. The root mean square voltage is V naught over square root of 2. Root mean square current is current sub 0 divided by root 2. Okay, let's get rid of that. We're going to talk about more on these equations when we do actual questions. We're just going through the equations. It's not going to be as helpful as if we're actually applying them. So we're going to apply all of these in the questions that we're going to be working out. Nuclear and particle physics. In a magnetic field, R equals P over BQ. In thermodynamics, heating, delta E equals MC delta theta, and delta E equals L delta M. So C is the specific heat capacity, and L is the latent heat. Could be of vaporization, or it could be latent heat of melting. Okay. Molecular kinetic theory. Half mc squared is 3 over 2 kT. PV equals 1/3 nmc squared. Ideal gas equation, PV equals nkt. Stefan Boltzmann law. And that one. Wien's law. Lambda max times T is 2.9898 times 10 power minus 3 millikelvin. In space, intensity is L over 4 pi d squared. The redshift of electromagnetic radiation, Z, equals delta lambda over lambda, approximately equal to delta frequency over frequency, approximately equal to V over C, velocity over speed of light. Cosmological expansion, V equals H0, H sub 0 D. Nuclear radiation mass energy, delta E equals C squared delta M. In other words, E equals MC squared. Almost there now. Radioactive decay. A activity equals lambda N. dN dt is minus lambda N. Lambda is linked over T half, and T half is the half-life, which is the time taken for the activity to reduce to half its original activity. N equals N sub 0 e to the power minus lambda. A equals A sub 0 e to the power minus lambda. So A is for activity, and N is for the number of radioactive nuclei. Gravitational fields. Gravitational force F equals G m1 m2 over r squared. You remember F equals K q1 q2 over r squared. So they are similar. But this one is for the force between two charges, and this one is for the force between two masses. Gravitational field strength, G is gm over r squared. Gravitational field potential is minus g m over r. Oscillation, simple harmonic motion, F equals minus ks. A equals minus omega squared x. X equals A cos omega t. V equals minus A omega sine omega t. Acceleration equals minus A omega squared cos omega t, where A is the amplitude or the maximum displacement. So the amplitude is the maximum displacement. P for the period is 1 over frequency, or 2 pi over omega, and omega is 2 pi f. Then simple harmonic oscillator, period is 2 pi square root of m over k, period is 2 pi square root of L over G. So this one's for spring, and this one is for string. Okay, so we've come to the end of some of these equations and some of these constants, which are mostly used for A-level physics. But you'll find that some of these equations you can also use for GCSE physics. So we've come to the end, but it's just the beginning of questions to come. It's really the questions that are going to make these make more sense, because as they are now, they probably will not make too much sense. So I'll see you in the next video, in which we actually start working questions out.